Alright, friends, we're live again. It's been a very long time, it's about 4 weeks now, but I'm back. Sadly, Martin could not join us today, so it's just me and the puppy. He's trying something new. He's now sleeping in his basket right beside me. Let's see. Oh, there we go. Alright, do not run the live feed when you are talking. So, alright, let's see. So, where did we leave off 4 weeks ago? It's been 4 weeks already. Lots of things going on. I actually passed my CAH version 9 exam, which is very good. So today we'll be coding again. Last time we had this very nice quantum Tic Tac Toe board. You could select some fields. The instructions would jump from player to player, which is very good. So we have this mechanism to highlight which player is currently active. We have some basic instructions, and when there's actually an entanglement or an entanglement, it will actually ask the other player to pick an observation. So first player 0 put the O's, player 1 put the X's. That created an entanglement, and that means that the player 0 is now asked to actually make the observation, and you could do that by just hovering over the path that was created, and currently it would just highlight the selection at that time. So what we should create now is that when we select a path, it actually creates the classical cells right here. This also works really well when you have a more complex path. Hello? Yeah, there we go. So player 0, player 1, player 0, player 1, player 0, player 1. It creates quite a long path, but it highlights all the relevant cells. So when you select it, it should default into, let's see, can we create a segment already? No. It would collapse into the classical cells. We already created some form of structure for the classical cells in our database format. We already said, well, entanglement should be replaced by classical, and the metadata, the turn and the player should transport into the values of this classical key. So we should make that. So we basically, when you click the path, it should say select path, and then pass the path as parameter to the event, and the event should modify the board. And what that should do, I had to look it up when I booted up the project again, because it's been so long. What that should do, when we go into the view, it will modify the board key to which this subscribe is done. It generates the cells, and when generate cells is called, it will basically do a create cells. That is right here, and create cells. If we jump to that, it will actually use our multi method that we created, the one up here, to actually create a cell based on type. So if you remember, the multi method had the classical version right here, a superposition version which just created the subcells themselves, which we called open. So all these little cells are called open cells. And the big one right here, the one that you use in the normal Tic Tac Toe game, when it has subcells, it's called superposition, and when there's an actual selection, an observation, it should become a classical field, a classical cell. So when we select a path, we click it. We should basically select the classical cell for this selected subcell and create a classical cell out of it, and then disassociate the entanglements. There's a case that we do not take care of really well at the moment. If there is a dangling pair, so say there's a O and an O here between those two cells. Currently the path only takes the main road, and then we would have a dangling cell. We can check that out later. I'm aiming at about a session of about an hour, and whenever I say that, it becomes maybe an hour and a half, something like that. So let's see. You might also notice that there's some changes to my desktop. I actually moved over to a Linux-based operating system instead of my Mac. That's due to lots of things. I will get into that in another video, but so far everything works quite nicely. So let's see if it holds during the entire screencast. So yeah, let's get cooking. We have this path that we can select. We have a very nice long path right now. So let's see where we actually do this. Yeah. So when the player state is observe, we see the other player gets to pick the observation, which is right here, which is the instruction. So the game state went into observe. When it is observe, we actually subscribe to the observables, and then when we click on an observable, we should actually start and commit to that path. Currently there's an on mouse over, so it seems that we can say on click. Let's create an event, dispatch select path, select path. No, I just want that one. So that should reload the UI, and we should actually get to, if we create, let's open up our console here. I'm actually using Firefox at the moment. I'm not entirely sure if that is what I will be using. There's also Chromium, but we'll get to that at a later stage, right? So yeah, so we did a click. We reloaded the code, all right, and now it should tell us there's no event, right? There's no event handler. So we go into the events, and we should toggle cells. Where's the highlight cells, right? Highlight cells, we should put it right here. Reframe, register events. Is DB, what should we do? We actually, let's first do a register event DB. We'll add the logic here, and then we can figure out if we want to move it along. Select path. Actually a function which has a DB, a event, and it gets a path. Right, so let's console log selecting path, right? Let's see what it does. Selecting path, right, and apparently path is an object at the moment. I would have expected it to be a, let's see what it is really. No computer? Matching, yeah, of course. We need to return the DB. Always return the DB, because else it does not work really well. And now it's not initialized anymore, so we need to, because we forgot to, or I forgot to pass along the DB again. DB gets unset, and then everything, a lot of interesting things happen, but reframe basically dumps all the state out, and that's it. Select one, alright, selecting path. I probably need to, let's first try a string version of it. Right, there's a string version. Alright, so it is a list, obviously. I could have figured that out all by myself. Alright, so we have this list, and now we need to just drop it into a, what do we need to do when we select, when we iterate over the path, we need to say, well, for this element, for supercell or superposition cell 0, subcell 5, we want to transport that into a classical cell on index 0, but with the metadata from our subcell 5. So let's give that a try. So obviously we need to map over. Let's first make sure that we have what we think we have. Console.log, making a classical cell, and we'll put that right there. So that should work, and we should see we should do all, because it's a lazy. Yeah, making a classical cell, and that is a vector, of course. I don't understand why this thing does not scroll, right? There we go. Making classical cell 0, 5 and 1, 0. So that's very good. And then if we have that, what should we do? Obviously it would be better to dispatch the changing of the cell, so we should actually, for every cell, dispatch to a piece of code that actually deals with just that one cell. So we have a very nice decomposition. So reframe, register event, that would be db, right? Make classical function which gets the db, and that gets a cell as a parameter, and let's make sure that that all works. Console.log, making classical stir cell, right? And then from here, yeah, doggy is having dreams. We should actually have we get a context, and then we need to keys db instead of row. I think it still gets the parameters, right? And then the result will be a map with db for now, and then here we will have a dispatch n. For every cell we have to dispatch a new cell, just like this one, but we need to basically construct that setup in a map, I think, and then pass it to dispatch n. So let's see, how would we do that? We'll actually go into a let dispatches. Oh, that's the wrong one. This one, right? And then from there we do this one, and dispatch n. Actually, we should make it dispatches, right? And then this map, basically, if we go into our REPL, so this map would actually construct, would this be workable? This and then that. And then it currently gets a list of 0, of 5, 1, 3, something like that, right? Would that actually do something? No. Let's see if PRN this will work. Right. All right. So passing a list to map with PRN works, but we want to create a vector. Let's see, would this work? This. That kind of works. We are not able to just do this, I believe, right? This. No, that gives an error. So the dog is having dreams. No, that sucks. Let's do this differently. Map, let's make it a function which gets data, and then we do a PRNE, and we make it a 0, 5, 1, 3. Let's see, yeah, that works. And then this one will actually return this. Right. Right. So we'll just do something like that, right? Let's move back right here. And this is obviously the path. So path, and then what did we call it? Make classical, I believe. Make classical, and basically creates a list of dispatches. I wonder if that works correctly with dispatch n, but we'll see. Making classical, it actually works in one go. Beautiful. I love it when it's working. All right, so what do we do here? We actually create a classical cell which has the turn and player from the metadata from this cell. So first we need to grab the metadata from the DB. The DB has a board. There is a board in DB. Get in DB. Yeah, we probably have it somewhere. Get in. We don't have any others. Probably in events, right? Get in subs. Get in, yeah. Get in DB board cell, and we know it is classic. It's not yet classical, so we need this key. Events. Yeah, right. So we need this key. We need and subcell is actually the second part of cell. And that is the first part of cell, right? We can actually destructure it right away because we already know it's subcell. So that makes that much more easier. Subcell, right? All right, so now we have the metadata. Let's see. So that's the metadata. The metadata will contain, if we go to DB, that will be this area right here. Because we say get us board cell that one entanglements indexed here. So we get this player turn. Player and turn are the ones that we're interested in. So maybe we can destructure that right away already. Let's see. We might already have it somewhere. Events. don't have it. So what we want to create, of course, is the classical structure, but we can just say we want to do two things really. We want to disassociate the entanglement and we want to associate the classical. So let's take the db and we will associate db. The key for it will be db board assoc in. Probably do that somewhere else already. No. It's been such a long time. Fuse. It's probably not a fuse as source. No. No, events. So let's see, assoc in db board, the index of the board, which is the cell, and then classical. And what would it get? It would get a turn, which gets turn from meta. Let's see if we need more player from meta. And then when we have that, we will do a dissoc db dissoc in. Can we do dissoc in? Probably. Can we do dissoc on a nested structure? Closure docs. Dissoc, can we do that? Yeah, we need to do an update in, right? So we do an update in, we have the db, then we do the keys board cell, and then in that we do a dissoc entanglements. And then from that, let's see. That gives us a new DB that should mark the classical cells. Maybe. Holy cookies. All right. That's interesting. It works. It works in one go. OX. Nice. Okay. Totally unexpected that that would work in one go, right? So that's also always very nice. Obviously, when that happens, we need to transition the game state. Currently, we have these observables, so we need to unset the observables. So when we have a select path, we do a dissoc. What do we need to do? We need to dissoc the DB's observables, right? That's what it's called. Keys, appdb observables. So this one should be disassociated. and we should do a dispatch of set state. We currently have this list of dispatches, so I'm wondering if we can just do this, right? And then set state, and that should be play, I guess, play. Play, observe. Yeah, and then in the view, observe is the state, then it does that, and else it just moves. Another thing we probably need to do is to change the player, right? Because when we toggle a cell, we do valid move, it marks the entanglements, determines if we should collapse, right? And then the switch player should be also propagated. So what do we get? We mark the cells, player selects the observation they want to do. The observation gets applied by toggling the cells. Then we get rid of the current observables, and player 1 gets to actually perform the next move. Right. Let's see how that goes. I'm wondering if this delay in this build-up is actually due to Firefox. I'll try Chrome. Right, your turn. You get to pick a collapse on observation. 0x. I want to. Oh. Yeah. Yeah. All right. So this probably. Maybe we can just concat it. It's a list, right? Is it 1, 2, 3? Four? What? That works for me. Conj. See if it does what we want. Let's close this browser. Let's open up Chrome. Right. Chromium, as this is called on Linux. The thing with Chromium, it is the high DPI stuff is not very well done. But it loads a lot faster, so I'm happy. Okay. Let's see. Right, that works. Beautiful. See if there's any errors that we need to take care of. Fail to load resource. Fav icon. Alright. Alright, so if we reload this real quick. Player 0's turn. Moves to player 1. Player 1 does the entanglement. Player 0 gets to pick. Let's make this goes back to player 1. Wonder if that's true, by the way. Quantum Tic Tac Toe Wikipedia. Let's see. Background, we have the entanglements, we do the collapse. Let's see. On each move, the current player, instead of one, each player selects two. For example, player one, next one, yeah, blah blah blah. Collapse is captured by specifying cyclic entanglement, causes measurement. Cyclic entanglement is a cycle of entanglement graph, for example. Well, that's what we already have. At the end of the turn on which the cyclic entanglement was created, the player whose turn it is not, which is player 0 in our case, that is the player who did not create the cycle, chooses one of two ways to measure the cycle. Thus cause all the entanglement squares to collapse into classical tic-tac-toe moves. We did that. Since player 2 created the cycle, player 1 decides player 1's options are dead. Any chains of entanglement hanging off the cycle would also collapse at this time. This is something we do not do at this time, so we need to fix that. But whose turn is it afterwards? When a move collapses into a single square, that square is permanently marked in large print. We already did that. It becomes classical. We did it. A square containing classical mark is fixed for the rest of the game. I think we did that. We need to check that. The first player, a square containing a classical mark is fixed for the rest of the game. No more spooky marks may be placed on it. That's a much cooler name. We should call that spooky marks, right? The first player to achieve... So the other player is not... I think it is... Actually, I don't think we should switch. It's actually... player 1 places an entanglement. Player 2 places an entanglement. It creates a cycle. Player 1 selects how to collapse that cycle. And then moves forward. So I don't know. Think it's unfair to switch. Let's give that another try. So now player 1 creates the cycle. Player 0 gets to say bam. And now player 0, you cannot click here, so we did that. It is fixed. Now I want this one, and now I want to make this X, right? So X, bam, do this, and now it is. Now I need to. Player O needs to. Ooh. X. Bam! It's a tie. Nice. All right. So we actually have our basic tic-tac-toe thing working, which is awesome. It only took us 30 minutes. But there's obviously problems, right? So if we do this, and we do this, and we currently have, we go from here to here, and if we now say O, there is a path selection, we click it, and bam. So we have this the cycle, and currently this one and this one should by default also collapse. Thinking about it, it probably makes sense to actually, when we figure out the path, to actually put the cells that will be orphaned by the selection of the other cells to be added to the path, the pairing of it, because that I think will automatically, given the logic that we hold, collapse these two. So let's get a test case. What is the smallest test case that we can make? Something like this, right? Yeah. So this is a good test case, I think. If we go to the DB, I believe we have some code to actually, where did we put it? Events. Yeah, there it is. So this is the actual board state at this time, right? So we will construct our basic example right here. Can we just select this? Right. There we go. We use some magic from Cider to say EDN format, EDN. Cider format, EDN region. All right. So this will be our test case. CPF. I'm actually, I switched to projectile for the for project management, so kind of getting the hang of that. I believe in the events. No, did we put it in a few? In the game test, probably, right? Here we have the basic test cases for the path helpers and stuff like that, and the observables. So let's create a orphan board, right? All right. So basically, what we want. Let's first. Yeah. So we will take the cycle find test case and say cycle find orphan. Let's remove all these out, right? And then we can say orphan boards. It probably what we should do is the cycle DFS, the depth first search, will give us the path, and then from that path we should basically say create another function that will harvest the orphans. That sounds rude. That will get the orphans from the board based on the path, and then append that to the list, and in that create its own its new version of a list. So let's start here. So if in the current orphan board we select 1, 3, which is the X, which is actually marked here, 1, 2, 1, 2. We should make 1, 2, 1, 2. Then we should get a list right away. So let's evaluate that. Right, CVW. That was not very good. There is actually an eval that will add it to a comment. C meta comma. Right. That was horrible. Let's see. There's actually, there should be one. All right. The current CVW replaces it. Eval UXE. This control UXE. That works. That works for me, right? And that's actually a list. All right, so that is our basic first test case. So this board, it should be 1 2 to 2 0, which is correct, to 3 to 1 5, right? And that basically eliminates this one from the equation because the path already has this entanglement right here. And that means that when the selection is done, the entanglements are cleared. So the ones that we should actually, we can iterate over the list, and then basically what can we do? Yeah, the top level cell will be marked, and that means that given the board, given all the other cells that are not yet in the path, we need to add those to the path. Yeah. But is that true? Because if we mark that as true, maybe it should just be a, well, you want to add that to the list. You when we highlight the path, we want to highlight the path of the cyclic entanglements, but we also want to make note of the orphans. So maybe we can do that in a different color or something, or have that listed as well. Let's first see how it does when we just add the path, and as they are added to the back, maybe with the switch to a classical, it will I wonder. Let's first just try and adding it to the back, see what happens. I think it will fail when we mark the classicals, because the classicals we basically do a dispatch n. So if you look at it from a non-single threaded field, it will shoot out 5 events for all the or 1 2 3 events for all the cells. That actually might work. Let's give it a try. So let's write out the logic. Map over path for cell, find all subcells not in path. So that will give us this one right here. Add find all cells. Yes. Add cell and found subcell with pair to path. Then it goes here. Wonder if there's actually one here as well. If we should, if it is the same as the that first search. I wonder if we take this approach, if we would only do one level of orphans. Probably can do with some nice recursion. I love recursion. Either it works or you're stuck for hours, right? So given that we have this, let's write our function right here. Find orphans. Board path visited. Let's see. New path. Accumulator. Let's just give it a generic name. So let's see if my basic iron. Okay. Let rest R would be rest path. That will give us the rest of it. So and the first cell will be first path, right? That's the one that we are looking at the moment. Then we have the rest of it, and then we for now we will say find orphans board rest, and we will add this to the conch do conch FACC. See, I'm not sure if this will work. I'm thinking it will actually give me the path that I already added now. Orphan board, the path that we already have, which is the path that was constructed, and then an empty accumulator. This will give us nil. So probably says that board is one. Probably does not work in closure scripts, right? Does not work. Then we just do if empty R conch FACC, that's that, right? We need to break out the loop, right? Right. I wonder, PRNF. Right, 1, 2, 1, 2, 2, 1, 2. It's not concat. go, there we go. Dee, 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 dee. One, two, 2, 0, 1, 2. And that should be reverse. Right, and that should give us the same list that went in, right? So we have that. Yay for us. So this is our breakout. And now that we have that, we need to actually say, well, great, we landed in this top level cell, which is by a 1, 2. And we only need the top level cell, so we should actually probably add a visited right there, because else we going. But let's continue. So we're at this top level cell, so we should PRN look at siblings for first F. So it should go look at siblings for first, for the 1, and then for 2. And it does not need to do a lot more. So we can say visited for the top level cells, and then visited becomes, it is an empty thing at the moment, right? So when we start it is empty. And visited will be, when we go here, v cons first f visited. Yeah, so cell will be first F. We can actually just say cell subcell, and then only here we need to add that to cell, right? Cell subcell, right? All right, and we have the rest, which is the cell. All right, and now we need to keep track of the top level cells that we were at, right? Let's first make sure that this still works. Only break one thing at a time. Right, that did not work. And that is due to us doing this, I believe. Cons 1, 2. 1, 5. that should work. That should work. Did I miss something? Yes, I missed something. Obviously, when I add the visited, we should pass the visited along, right? Visited. Right, so that gives us the path that we already wandered through. Okay. Let's get the dog is streaming. Let's get the siblings for the entire thing. Game. Do we have a siblings? No, I think that first search, which is in game, get other cells. Yeah. That first search gets the other cells. Get other cells, is that the pair? No. Get in boards. Get other subcells. Yeah, so we can use get other cells. Which is also used in that first search. So others is already there. Then pick path, right? School is that we already there, right? So we just follow the pairs, right. So basically to get other cells is what we need, and that is in the system under test. So for now we can say others get system under test, get other cells or from boards, right? Cell, subcell, cell, subcell. I'm looking at siblings and PRN siblings. Others. I wonder what it does. It will probably tell us that for 1, 1, 2, there's one at 0, right? For 2, 0, there will be 1, 2. Oh, we start reverse. So we start at 1, 5, so it lists these two. So 1, 2, and then it moves to this one 2 and then 0, then it moves to 0. It should list to 3, right? And then it moves to here. Alright, so now we need to remove the cells from others that are also in path. Seems like something that is already closure. Remove common cells. Remove common duplicate items from list. Distinct from two lists. Dedupe. Would that be? No. Items from common elements into a list with duplicates. One. I wonder if we already not did it in game. So remove visited map vector cell first. Vector cell. Oh, yeah. Yeah. Okay. So probably we can remove others. Non-path others. Let's give that a try, right? Remove from others the vectors from path. Yeah. More and more I am not liking it. Yeah, this is horrible because it's not the same type of thing, right? This is something to really think about. I think we need to fix it with a new depth first search. I am wondering. Because a lot of the things that we already did in the depth first search can be applied here. But in the depth first search, we actually went to the pair, and then from the pair we looked at other cell, went into that pair. I think we already go into this one with game depth first search. Let's see. So it seems to me that we already go here. curious about if cell 0, 2 actually makes it into the path right here. Obviously we do a if we take this, we need this one right here, find orphans. So if we start here, do we actually get to board 0 as well? That's the question I have. So it moves right here, but I'm thinking that that first search with the others right here would actually also list this one right here. And if that's the case, then all we need to do, what we need to do is actually change a little bit of the logic of our depth first search in order to actually get the orphans as well. Others tree. We start at 1, 2, 2, 0. That is what we already have. Yeah. Find cycle D of S. Yeah, okay, because we already jump into the next board, so we already jump into the pair. We don't see this one here. But it seems we can reuse our depth first search logic to actually find orphans, right? Control. This is not here. This is in the system under test. Reds. This will be orphans. Cider indent. Right, and then gets the entangled pair, system under test, right. Right, and that seems like something that will take about an hour, and that will be what we do next week. Yeah, we'll do that next week. So for now, what did we accomplish? If we reload our application, we are able to create a cyclic entanglement that makes our game fun to play. And we actually have a working board. So from 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. It is beautiful. So we actually have a form of Tic Tac Toe. So next week we'll make sure we deal with the orphans in the board. That means that we are able to actually perform the entire collapsation of the path. And we will make sure that we can detect the win state of the board. Obviously, this state means that there's no winner. If we move it into a 3 in a row, it should actually say player 0 or player 1, you won. But we'll do that next week. So I would like to say thank you for watching. I hope you enjoyed it. If you did, give it a thumbs up. If you've not done so, subscribe. There's already more than 700 people following the channel. So that's awesome. Up to, let's go to the 1,000. Yeah. See you next week, Friday, 10 a.m. Central European time. And have a good day.